Hello, this is Aaron Maller from Parallax, and this is just a quick video to go over some low slope roof modeling and how to shape edit with tapered insulation and such without getting a lot of bizarre triangulation that we were talking about on the forums. This is just a quick sample I mocked up. Basically, I've got a low roof and then I've got some high roofs. That way we can look at what happens at all of these corners and such. This is a quick, dirty sample. This is not going to be the most well thought out roof design there is, so don't pick apart the demo over some strange slopes and things that would need to be rectified with steel heights and whatnot. But let's assume for right now that basically we were going to put a ridge in the middle of the roof so that we could shed water in each direction, like so. And then obviously we need all this water to come down to these drains, including getting it around these pop-up roofs as well. And then of course the tall roof will go to its own drain and similar up there as well. Okay, so what we're going to do is, as the first part of this, if we were to come in, and I don't normally shape edit down to a point, I shape edit down to a small rectangle, but just to start off the demo, I'm going to use a point just to be lazy. So let's say that I had started shape editing this roof and I had connected what I thought was going to be all the high points, all the low points, and then I lowered this thing, let's just call it 2 feet. Obviously we're going to get this kind of mess. A whole bunch of stuff is going wrong here. But one of the first things I want to talk about is that also, when we tend to just draft these roof plans out, we say that we want this to be the high point and this to be the high point and this and this. But that does actually leave this whole area along these walls as if they're at the same elevation, which creates kind of a weird dished curved shape over here. So all that to say, this obviously does not look like something that we want to present to anybody, so I'm going to just reset that. So one of the things that we'll do when we need to model roofs like this is we'll look at basically the largest simple shape that we need to make that will create the roof slope that we want to get. So if I look at this area right here, that's basically the theoretical would-be area that we would be driving down to this drain. So right now, I've also got the hole sketched in here. So I'm going to temporarily take that out. And I'm also going to temporarily change the shape of this roof so that it's a lot larger than it is on the real building, like so. Now, if we do this, a few things happen. One, it's suddenly a lot easier to achieve the general slope that we want in terms of, we'll go down to a single point because that's what we said we were going to do just for the demo. So if I now slope to these 4 points, and you wouldn't just necessarily set these 4 points at the corners, you would set them wherever your actual top of roof edge was going to be, in conjunction with your structural file and whatnot. But if we do this, and then we go to lower this, it's absolutely going to do exactly what we wanted it to do. The only caveat now is that we've got a bunch of extra roof that we don't need. So here we can come in with the vertical opening tool, and this is what I was alluding to on the forum. This is what I see a lot of civil engineers do when they model, is we can then use vertical openings to rip out the sections of roof that we don't want, because Revit's going to basically respect the order of operations in a sense of the shape editing was done first. Actually, it might not even be operations order, because I think you can do this and the shape editing anytime you go back in to edit it, those points are all still there. So you can basically always edit the original shape doing it this way. Now this looks goofy because of where the lines are, and again, this is going to come down to actual roof design, but it is actually doing what I would want it to do in this situation. So let's isolate the roof so we're not getting spot elevations of the wall. So we do have a consistent top of roof edge there, and then here it is actually sloping as it goes, which is what I want it to do because this is a planar sloping roof shape. So once it gets to here, that is planar, it's flat or consistent elevation along that edge, and that's because this plane of the roof started at this elevation and sloped its way down. So we basically have the slopes that we want, and I just threw a number in there for the slope, but they're consistent and we don't have roofs warping everywhere. And now we just have kind of our edge case situations to deal with, which is kind of cool. So doing the simplified shape followed by the vertical openings to strip out the extra space that you don't need is one way that you can actually model these things a little bit quicker. Now that leaves us with what we were discussing on the forum, which is we're still going to need a bunch of tapered insulation because this is not going to fly, of course. So that's where we'll do a similar approach where we'll have another roof, and I actually just keep one that has a hatch pattern on top of it. And the one part that this will not address, of course, is the hatch pattern will be strange if we model it this way. And I basically pick a generic pattern that's just meant to say this is going to be tapered insulation. And the fact that the hatch pattern is weird is not graphically super pleasing. But so right now it is because I haven't edited it yet. But what I was going to say is one of the tricks for doing this that I've found works really well is even though they're not all overlapping properly, that's okay. I'm going to just temporarily, well, I'm going to keep them joined, but I'm going to join geometry, the main roof, to the tapered insulation. Because then if we go in with shape editing and put the center line that we need right through the tapered insulation, because we did join geometry, these points will actually snap to the roof. First, I need to lower this thing some more because I used a roof type that's not very thick, so we're going to just lower this. And this part stinks. We're just lowering it enough so that we can have it be below the roof, but you'll see that it is actually going to snap at this point to the actual elevation of the roof. So if I pull it up beyond the slope of the main roof, we now get a hard edge because we've done the join geometry, and then when you pull it back down, it will snap to that roof. So what that allows you to do is with some careful finagling, you can drop those things into position, and now we know we need to raise that point to get the crickets where we want them. So I'm going to just pick a number to start, and then we're going to look at some slopes. So that's at 7/8 of an inch, 7/8 of an inch, or so that looks good. And now we've basically got those. These things will warp, and the pattern will look stupid at some point, and that's a product of it being a strange shape that's on top of the Revit object, and the drafting pattern will sometimes warp and be turned and twisted and all kinds of things. But it makes modeling these things very quick without needing a bunch of voids and without needing a bunch of in-place families, if you will. So I would do a similar approach for the rest of the roofs as well. This one obviously is just the second half of the big one, but then if you wanted to do the same thing on the upper roof, at that point I would make the simplified shape and then say I want to add split lines to this, and of course this is just going to be goofy because of where I put the drain. I was just kind of doing something, but essentially if we were doing this, by the way, I would not slope the roof this way. I would slope it in one direction, and then I would have tapered insulation everywhere. That's basically what I would not do this, but let's just say you wanted to. So if you were to do that and then lower it like a few inches, and then you can vertical opening, strip that thing away, and it will cut everything off like so. And again, what we're really after here is if we were to go look at it in terms of our spot elevations, is we want this to be consistent because we're starting the plane that slopes down in this direction. So this edge should be changing as it runs along, but then of course these are all going to be level because at that point, whatever structure is there is all going to be level across that wall. This obviously is not really how we would do this. So again, that's just because of how I'm kind of doing this demo. But that's basically what I do to make it so that I don't have to use the adaptive component solution or the in-place voids or the modeling individual planes of roofs, which I've seen folks do as well. It takes a little more finagling, like in this case, to figure out exactly where these points are going to be. So, if you were to talk to or review with structure and find out that they were going to do something where, this was like a top of steel elevation, but then, they wanted this piece sloping down to come all the way down to here, so that then this ridge or this valley ran to that corner, you would have to finagle where you've put this point, or basically what you'd have to do at that point is draw a split line such that it goes from here through that corner instead of the one that I've drawn to the left that goes all the way to the corner. You basically have to do something like this in lieu of this first line, and then you can adjust that as well. But as a technique, it's pretty repeatable, and I haven't found a lot of projects that it doesn't work on. So that's basically what we do for the low sloping roof conditions. Just thought you might want to check it out.